Okay, guys, welcome back. Let me first go talk about the recursive query. So, just speaking, what do you mean by the recursive query? Recursive query is the way that allows you in order to simplify a very complex query. Okay, sometimes you try to say query hierarchical data. For example, that like organizational structure. We have, for example, you need to find the manager of every single employee in the data, or you need to find the prerequisite for every single course, either direct or indirect prerequisite. How can you perform this one? We're going to do this one using the recursive query. So, yeah, let me jump. So, give you an example. Assume we give you this data, and you said, I'll ask you or require from you to find which courses are prerequisite, okay? Whether direct or indirect. So what does that mean? I give you, for example, course CS425, okay? 347. I ask you, give me what the prerequisite, the direct or indirect prerequisite to this course. So in this case, you're supposed to give me what? The direct prerequisite is going to be CS319, right? And the indirect, because this course has a prerequisite to other courses, okay? So in this case, the result is going to be CS319 as the direct, and also you have to say 315 and CS101. It's going to be indirect prerequisite for the course CS347 because they are the prerequisite for the course CS319. Then again, for the 351, so you can display the prerequisite of this course, we're going to be CS190, and for the CS190, it's going to be like, they have to say, display or produce, the prerequisite course, in this case, could be CS101. How can I solve them? How can I write SQL query in order to produce this result? The easy way to do that, we're going to use the recursion or recursive query. So the recursive query is going to be similar to the way that we did with the class. Remember we did this one before? We talked about the common table expression, okay? Which is going to be in the SQL with the class, which is going to be like defined as a SQL with the class. Okay, which allow me in order to help me in order to simplify the very complex query. So in this case, we did this one before with the name of the, let's say, common table expression, and you can say as create a SQL, and this relation or temporary relation or this table can be only used within this query. Then after that, you're going to select whatever query from, then you're going to use this whatever of the table you just to display or what just to create. Okay. That's what we did with using the common table expression, which is defined as the SQL with the class. So now we're going to take a look, see how can you use one in order to help me in order to what? In order to help me in order to build recursive query. Okay? So, in the way that to build recursive query, it's going to be something similar to the following. We're going to use the with the class, and then going to say with recursive. This is the standard, how they define this one. We're going to use a common, say, table expression, which generates a temporary table. But the way that we generate this one, we're going to have, it could be two parts. We have two parts in this query. Okay, the first one, we're going to have the non-recursive part, and we have another recursive part. So what does it mean, the non-recursive part? It's going to use, we're going to use this part in order to create or define, to say, the base result set. Okay, so here we're going to use common table expression structure. We're going to use it with the class. So it looks like we're going to create a base relation, and we're going to use this base relation in order to create another new relation. And we're going to see if we use whatever the relation that we just created in order to help us in order to recursively create another relation, and etc. As long as you create a new relation that contains a data, so you're going to continue this operation. So again, the recursive, actually, we can generalize this one, actually 3 elements, not true, because if we include the third part here. Okay, the first one, sorry, we're going to have the base relation, which is going to be the non-recursive term. This part, whatever you write, this one is going to be only execute one time. Then this one is going to be used to the base relation. And base relation, assume going to be used called R0. Let's use R because this is the result. And every time you're going to, in every single iteration, I'll produce R0. I'm going to produce the first one. Then after that, I'm going to use the R0 with the original relation, with another relation formed somehow in order to create R1. Since R1 have data, I'm going to do this one also in order to help me in order to create R2 and etc. So this is the initial query, can be executed only one non-recursive part, and this recursive part is going to be executed many times. Okay, every time we're going to produce one portion of it. So we end up, we have, for example, R0, R1, for example, Rn, something like this. Then after that, you're going to do what? You're going to perform what's called, this is going to be like common expression table, a number of them, many forms. You need to union them or collect them in one relation. Then after that, we're going to, when you union them, we're going to produce the final result of R. And now we're going to use the common expression table as a normal relation. Again, this kind of recursion is going to allow me in order to access the query that has the hierarchical data. For example, I give you this data, course ID, the prerequisite ID for every single course, and I ask you to give me, for example, what the direct and indirect prerequisites for a given course. The direct prerequisite for this course, for example, 347 is going to be 3119. The indirect with this one, for every single prerequisite for this course, I need to find out what the prerequisite of this course. And for every single prerequisite course, I need to find the prerequisite of the next course. So in order to solve this query, I'm going to do something like this. First, I'm going to produce R0. Somehow I'm going to see that contains the direct prerequisite for this course. It will be CS425, the course ID, and the prerequisite ID is going to have, let's say, the CS319. Then R1, I'm going to use this one in order to produce R1. R1 is going to have the course ID and the prerequisite ID for what? For every single prerequisite course that we got from R0. So CS319, the first course is going to be CS315, and CS319, I'm going to have CS101. Then R1, I need to produce the same one, course ID and the prerequisite ID. And every single prerequisite ID that's in the previous relation, you're going to use this one in order to find out the direct prerequisite for this course. After you're done, until you reach, for example, whatever Rx that contains nothing empty, that means you have to stop creation, then you join all these attributes, this sub-relation that we have in order to build one big, let's say, common expression, common table expression value, which is going to be used in the query. So this is how it looks like. We have a recursive part, a non-recursive, and the recursive part. And we have a termination check with the one that as long as this relation contains, or the recursive part is going to produce the relation that contains the data, then continue this operation. Okay? So let's see how can we execute that. How can we perform this one? So first, when you try to execute this one, the system is going to first execute the non-recursive part. And this recursive part somehow is going to treat what? It's going to access to the original relation or the given relation in order to give us the base relation. Then after that, for every single version that we got from here, it's going to be only one time to execute. I'm going to keep executing the recursive part. I get whatever the input, let's say Ri, for example, the iteration I, take the value of Ri minus 1, whatever they have the pace or the relation that produced on the previous step, injected with the original relation somehow in order to produce another value or another table R1. Use R1 or Ri in order to build for the next iteration. So I is going to be 2 here. I'm going to use the R1 with the original relation in order to produce the second relation. And it has the same structure. The only thing you need to figure out, how could you come up with a base query and how do the recursive? What you need to do this one recursively. If we take a look in our case here, what I need to do at the beginning, I need to find only the direct, let's say, prerequisite for the course, given course. How can you do this one? You can select, in this case, you say, you can say this part, the first one, okay, select. Let's say what you need to have. You need the course ID. I'm going to use CID and BID to simplify the process. Okay, from where? From this relation. What's the name of this relation? S. Assume this relation S, okay? Where? What you need to do here, I need to have the course ID is equal the given course CS347. I need to perform this one only one time. This is only the base relation. I need to find the direct prerequisite for the given course. Okay? I will call this one R0. Good? This is the non-recursive part. What you need to recursively repeat. What we're going to do recursively, you're going to take everything for the say from in the iteration I. I'm going to use the Ri minus 1, the previous value of the version that you receive from the previous step, And in this one, I need to do join with what? The original relation S. What I need to do? I need to take the, let's say, assume the I minus 1 dot the prerequisite ID. Whatever you have the prerequisite ID from the relation that we have R0, remember the R0 is going to have what here? Then the course ID and the prerequisite ID. The course ID is CS347 and the prerequisite ID is CS319. Recursively, I will take the prerequisite ID for this relation, okay? And they use this one in the original relation to find all the direct, they say, prerequisites of this course. That's what I'm going to repeat this one. So for every single value Ri, relation Ri, you always take the prerequisite ID from this relation, use it as what? Equate it with as a course ID in the original relation to find the direct prerequisite of this course. Okay, so in this case, the prerequisite ID, equate this one must equal the course, let's say the S dot course ID, in order to find all the prerequisites. So what we need to, in this case, we need to have select the course ID and the prerequisite ID from the relation S. I compute, for example, R1. Since R1 has a data, I will do the same thing. I will take from the R1, you have a course ID, and you have a prerequisite ID. For the course ID, for example, CS319, and the prerequisite ID, if you have CS101, and you do have a CS3115. Recursively do the same thing. You're going to take the prerequisite ID from the relation I that had R1, and join, you take Ri with, or Ri minus 1 join with S, and do this one the same thing. Take the prerequisite course from the Ri that we have minus 1 as input, with this case R1, and equate this one with the course ID from the relation S, and you need just to retrieve the course ID, the prerequisite ID from the relation S. The produce R2, and etc. Clear? Does that make sense to you? So anyway, this is the recursive part. Thing you need to only one time, execute one time at the beginning. Then after that, this one, the recursive step. What you need to do this one over and over. You are gonna stop until you're not gonna stop here or exit from this part until this one again produces, say, empty result. Then after that, now we have many versions, R0, R1, and etc. You need to combine them in R. Then after that, you're gonna use R, which is gonna select all the data stored there. So in our example, assume that for simplicity, assume that we have table called S, just for simplicity here. Okay, I use S just to simplify the process. Create course ID, the prerequisite ID, and fill this one with data. Okay, this is if you try to practice, do this one. Okay, now I need to write my query here. I assume that I'm gonna use R just to simplify the process here. Okay, then you have the course ID, the prerequisite ID from what? From the relation S. Remember, this is the base part. Gonna be executed only one time. So in this case, I need to find the direct prerequisite for the given course. So in this case, we have a course ID, and the prerequisite ID is going to contain what? The course ID CS347, I guess, CS319. Only this input. Done. This is the base relation. I will call this one R0. Okay? Now, I'm not going to perform the unit. Now continue the recursive part. This is the recursive part. What you need to do in the recursive part, you're gonna take for whatever you produce in previous step with the previous relation. In this case, R0 I have. Use this one, the prerequisite ID, and you need to find out all the prerequisites for this course. So I'm gonna use whatever we have the prerequisite ID in the previous step or the previous relation, use it as a course ID in the relation S in order to find all the direct prerequisites of this course. How can you do this one? I'm gonna say select the P to say the course ID, the prerequisite ID from the relation S. I'll assume this S simplicity here. And now join with R. I call this one R, right? On what? Use this one, the prerequisite ID from the relation S is equated with what? The R0 dot the prerequisite ID. Right? So this means I use this one as an ID, check for the original relation to find all the direct prerequisites for this course. Do this one, it's gonna be R1. For the R1 again, I will do R1, then I will stop, okay? Course IDs, prerequisite ID. For the R1 is gonna be the course CS319. The direct prerequisite is gonna be CS1, CS11 something. I don't remember that one. Okay? Then for each of them, you gotta produce this one for the R2. Use R1 prerequisite ID as a course ID in order to perform the operation. Once you're done with the whole thing, now you need to do what? Once you're done, that means you have one relation that has empty. You end up you have one that doesn't have any prerequisite, or you don't have anything here. So in this case, you need to do what? You need to join all of them in one relation. So in this case, it's gonna be in our case, it's gonna be all of them gonna be joined under R. Then now you can select all the information from the R. Within this display, will give you the final or the correct result that I'm looking for. Okay. It's great if you use this one, and the problem if you try to answer this query using, whatever we learned so far for the textbook, if you take a look to the find all the prerequisites here, you're gonna see that it's gonna be large and many. We do have like a large chunk of code in order to execute this one. For the using recursive, it's gonna be great.